Welcome to our video on College Board's SAT Test 8, Section 4. We're going ahead and doing all the solutions and explanations for this test. And the best way to do this, if you're watching after the fact, would be to pause the video, try each question on your own, and then go ahead and look at our answer for the most effective way to do each question. Gradeful could be tutoring you or your child one-on-one online, regardless of where in the world you live, starting as early as today. So today might be your day to start pursuing your college dreams. Let's go ahead and get started. So question number 1 says, 1 pound of grapes costs $2. How many dollars will C pounds of grapes cost? This has right here the sound of a proportion. It just should sound like that when you're reading it to yourself. So 1 pound costs $2. So C pounds cost how many dollars? And notice that in order to do that, I had to kind of rearrange the way it was being said. If it was exactly set up as a proportion in the original question, that would almost be too easy. But if you need a little help with this, you can actually write out the units, pounds and dollars, and maybe even write before and after. So we can say 1 pound costs $2 and C pounds costs how many dollars? So actually, I think this, being question number 1, a nice easy one, or intended to be an easier one because we're just starting, I think it is actually in the order of the proportion you can write, right? 1 pound is $2. How many dollars is C pounds? No, it is actually reversed a little bit. But in any case, when we have a proportion, we can cross multiply. So we'll say 1x equals 2 times C. And just notice that we're looking for, the variable we're looking for is the C. It's the number of dollars that C pounds will cost. So we'll solve for X, and X is actually just 2C. We already have it. And the answer for number 1 is going to be A. Going over to number 2 now. Tracy collects, sells, and trades figurines. She tracks the number of figurines in her collection. On what interval did the number of figurines decrease the fastest? So the idea here is that increase and decrease could be just a code word for the idea of slope. And so if we want the fastest increase, that would be a really steep slope upward, or the fastest decrease would be really steep in the downward direction. And also the other thing is that when we're talking about slope, we're going from left to right. So where is this because we're looking for a decrease, where is it very steep in the downward direction? And so right here in purple, we're on our way down. Right here in pink, we're also on our way down. And those are the only 2 places that the graph is on its way down. And the pink one is clearly more steep than the purple one. So between 3 and 4 is going to be the answer for number 2. And the answer for number 2 is C. Going over to 3. A random sample of 200 cars of a particular model 3 have a defect. At this rate, how many of the same model will have a manufacturing defect? So once again, 2 questions on this, and we just started. The sound of a proportion is what we're seeing here. So if we just think of the idea of number of cars and defects, the question is saying if we have 200 cars, we have 3 defects. Therefore, 10,000 cars will have how many defects? So arguably, it's in the order of the proportion we need to set up. Arguably, it's not. But in any case, you can go ahead and label it like we did here to kind of have more clarity on how to set it up if you are at all confused by that. And once again, we have a proportion, so we can cross multiply. So 200x equals 3 times 10,000. Multiply the 3 times 10,000, 200x equals 30,000. And now we're dividing both sides by 200. 30,000 divided by 200 is 150. So the answer to number 3 is going to be A, 150. Now we're going to number 4 here. So number 4 is a nice common question type we're going to see a lot of on the SAT. We're talking about actual values versus predicted values. Actual versus predicted. Actual will be the dots. The prediction will be the line of best fit, usually. So here, we're saying the width is going to be 19. So we're going on the x-axis to where the width is 19. So that would be somewhere around here. And we're saying what's the predicted length? So not the dots, but the line. And where's the line going to be when x is 19? So where's that value right there? Just looking, it looks like 55.27. But we can know for sure because we were given the equation. So in other words, what's the height going to be when x is 19? What's the y value going to be when x is 19? So we'll take the original function and we'll put in x equals 19. And we'll go ahead and solve that. 1.67 times 19 plus 21.1. And that gives us 52.83. So the answer to number 4 is going to be C. Going to number 5 now. My screen jumped a little bit, but going over to number 5. Here we have the idea that L and M are parallel. Y equals 20, Z equals 60. So let's just start filling out some of those stats there. Y is 20, Z is 60. And, you know, there's a lot of ways to approach this, but the thing that I would like to emphasize the most is that with parallel lines, you want to look for C's and Z's. So I'm going to draw 4 sets of parallel lines here. And the idea is that with parallel lines, you need to look out for C's and Z's. If you have a C shape like this or like this, you need to know that the inner angles in there add up to 180. So here, angle 1 and angle 2 equals 180. And here, angle 3 and angle 4 technically is the measure of angle 3 and the measure of angle 4 equals 180. And if instead of a C shape, we have a Z shape, like that or like that, then we need to know that the two inner angles of that arrangement are equal to one another. So here, angle 5 equals angle 6, or the measure of angle 5 equals the measure of angle 6. And here, the measure of angle 7 equals the measure of angle 8. So although there are lots of ways to proceed on this, just keeping it consistent with tips that you might need for future SATs, I'm going to go ahead and see that there's a C shape right here. And these two, let's go ahead and use the same color we used for our other C shape. These two inner angles here have to add up to 180, just like we have in green on the right. So therefore, this has to be 160, because 20 plus 160 is 180. Now, by the way, when you have two angles that form a straight line, in this case A and B, A plus B equals 180. And that's exactly what we have right here. Those two angles are in the same arrangement. They equal 180. So if the bottom angle is 160, the top angle has to be 20 for the two of them to add up to 180. Now we've got the triangle on the top of this, and we have two angles of that triangle. So the angles of a triangle have to add up to 180. So we already have 20 and 60. We already have 80. So for x, we need the extra 100 that makes the triangle add up to 180. So what's the value of x? It's going to be b100. And we talked about a few good rules here. For parallel lines, you need c's and z's. And for a linear pair, the two angles add up to 180. So the answer number 5 is B. And let's go over to number 6. Number 6 is a system of linear equations kind of set up here. And the big thing we emphasize with the systems of linear equations is to be really clear on what your variables are. So they spelled it out for us, but they also gave us so much more information that it's a little overwhelming. You know, this is the one that people would call, quote unquote, a word problem, even though most of the questions in the SAT can be referred to as word problems. But in any case, they're telling us that B is the number of bench seats. If I can get this to work. The number of tickets for bench seats. So B is the number of bench seats. And they tell us that L is the number of tickets for lawn seats. So L is our number of lawn seats. So just being a little extra clear on that can give you the extra peace of mind that would allow you to easily put these sentences together. So the total number of seats, which is B plus L, well, the total number of tickets, I call them seats, but the question is referring to them more as tickets, is 350. And when you're dealing with systems of linear equations, the big thing to look out for is the idea of price times quantity. So for instance, if I'm buying 3 sweaters and they each cost $15, I'm going to pay 3 times 15. So 3 being the quantity and 15 being the price. So we're always looking out for that. And price is not always money. It could be just the idea that, you know, that puppies weigh 5 pounds and kittens weigh 3 pounds or whatever it is, right? But the number that comes along with each item is what we refer to here as the price. But here it's the actual money, and the actual money brought in is $19,250. And that's your price times quantity statement. So the number of bench seats times the price of a bench seat plus the number of lawn seats times the price of a lawn seat, which is 40. And now we've got our two equations. B plus L equals 350. 75B plus 40L is 19,250. And that seems to all match choice D on number 6. Okay, going over to number 7 now. If you're watching this video in real time, I would love to get a little comment from you, just the word hi. You know, we're just starting this operation, and it's nice to know that there are people out there with a pulse. So if you would just comment hi to say, hi, I'm here, it would mean the world to us to let us know that little by little our videos are starting to reach people. Let's look at number 7. The graph of which of the following equations is a line with a slope of 3? So when you're looking for slope of a line in its most fundamental form, you have y equals mx plus b. That's the slope intercept formula of a line. We use it like crazy on the SAT. And if you have something in that format, then m is your slope and b is your y-intercept. And so which of these has a 3 in front of the x where the slope goes? And that would be this one right here. So the answer number 7 is C. Nice, straightforward, easy question for us there. Not so much the case for number 8 here. Number 8 is asking us for a value of x plus 1. So our natural instincts here, which are to set up something that could be factored, would actually cause us to miss a nice, easy thing that we could do to solve this question. So for number 8, The starting sort of issue is that we have x plus 1 on the bottom. That's not the place where we want to see a polynomial or a binomial. We'd rather not have an x expression on the bottom, but we can get rid of that quite easily by multiplying both sides by x plus 1. So on the right-hand side, you've got x plus 1 here on the top, because on the outside, that's x plus 1 over 1. So it's on the top of the fractions in the numerator. Cancels against the x plus 1 that's in the denominator. So we have that cancellation. And on the right-hand side, it would be really tempting to FOIL that out right now and get x squared plus 2x plus 1. But instead, let's leave it as x plus 1 squared. So that's where we are right now. So now, how do we get x plus 1? Well, we can undo the exponent of 2, the square, by just taking a square root. And remember, when you take a square root, you get a plus and minus. So x plus 1, because we have the square root and the square canceling each other, equals plus or minus the square root of 2. And that's what they're asking us for here. So it would be really easy. Well, so, okay, that's going to be our answer there. But it would be really easy to subtract 1 from both sides and say that we have -1 plus or minus radical 2. And then to go ahead and pick an answer like A based on that. So just be really careful. When you're taking an SAT, the moment that you pick your answer, the moment that you bubble it in or fill it out or circle it or whatever, should be the moment when you say to yourself, wait a minute, was that what they were asking me? Is there anything I missed? And, you know, the SAT being such a tricky test, the answer to that question is often going to be, yeah, look out. There's a little trick there. And that might be your last chance to catch it so that you don't find out 3 weeks later that you got the question wrong after you thought you'd gotten it right. So let's look at number 9 now. What is the value of K in number 9? So what are they telling us here? They're telling us that the volume of the cup is 7 pi k cubed over 48. But then right here, they're telling us that the volume is 473 cubic centimeters. So they're both equal to the volume, so they're equal to each other. So let's go ahead and say 7 pi k cubed over 48 equals 473. And now we're just solving for k step by step. But we also want to move as expeditiously as possible. So let's talk about maybe like the fastest way to proceed here. Can't seem to get my handwriting right here. There we go. Okay, so we would love to have k cubed by itself, so we can then just take the cube root and find out k. So the way to do that is to multiply both sides by 48 over 7 pi. Because we'll cancel out the 48 from the bottom and the 7 pi from the top. So I got to do the same thing to both sides. So now we have 48 and 48, 7 pi and 7 pi, and we bring down k cubed. Now be careful on your calculator. On your calculator here, you have to say 473 times 48 divided by parentheses 7 pi. Because if you do divided by 7 times pi, your calculator is going to think that you're doing 473 times 48 divided by 7, and then we're multiplying everything by pi. But that's not what we're doing. We're dividing everything by 7 pi. Tiny difference that would result in an answer that's off by a factor of 3.14 squared, if that makes sense. So just be careful on your calculator. When you're dividing by 7 pi, use parentheses. And we do recommend you use a graphing calculator like the TI-84. If you're using the TI Inspire, check the College Board website and make sure that your TI Inspire is allowed on the SAT, because a couple of models are not allowed, and you don't want to find that out the hard way. So 473 times 48 divided by 7 pi with the parentheses around it equals 1032.4. Now we can just take the cube root of both sides to get rid of the cubed on k cubed. And so now the cube root of k cubed is just k. And the answer is the cube root of 1032. Now again, on your calculator, how do you take a cube root? Cube root of a number is the same as that number to the 1/3 power. And the square root of a number is the same as that number to the 1/2 power. So just a little thing there that you may not realize, you don't know how to do that until you try. But the cube root of 1032.4 is 10.106, so 10.11, which matches answer choice D on number 9. So now we're going over to question number 10 here, which is on the right. Go ahead and delete this information just to have less distractions on the screen. Maybe we'll get fancy a little bit here as well. So question 10 says, water pours slowly into the glass at a constant rate. Which graph illustrates the height as it fills? So the idea here is if I have a Coke can, a perfectly cylindrical, despite my picture, it's intended to be perfectly cylindrical, perpendicular to the ground. That's different than having a can or a cup that is more narrow at the top, kind of like a chemistry beaker. And that's also different than having a cup that's wider at the top and more narrow at the bottom. So these are three arrangements of what we could have. We could have it sort of be perfectly even, more narrow at the top, or more wide at the top. So in the first one, as we fill it at a constant rate, it would fill at a constant rate. Nice and easy, nice and simple. The second one, as we fill it, notice that the cross-sectional area gets smaller. So like right here, that would be the cross-sectional area. But once we get to this level, this would be the cross-sectional area. So the area of what you're filling becomes smaller the higher you go. So as we're filling it, it's going to fill faster and faster and faster because the same amount of water is now filling less space. It's going to fill up faster. But the opposite is true here, where immediately there's not that much cross-sectional area to fill. But the higher we go, the more cross-sectional area there is to be filled. So as you do this graph here, the higher you fill it, the longer it takes to fill because you're filling more space. So this picture here most closely resembles this picture here. And so the answer to number 10 is going to be C. Going over to number 11 now. Let's go ahead and just bring the scenario in so it can be close to question 11. Okay, Jenny has a pitcher that contains 1 gallon of water, 1 gallon. How many times could she fill the glass? So we can view this as a unit conversion problem because we have 1 gallon and 1 gallon is said to be the same as 128 fluid ounces. Now, like we always say, this fraction here is equal to the number 1 because if 1 gallon is equal to 128 fluid ounces, then all we have there is a fraction with the same number on the top and the same number on the bottom, the same values on the top and on the bottom. So that's just the number 1. And we're allowed to multiply something by the number 1 because when you multiply by the number 1, nothing happens, right? So we're allowed to do nothing. However, here they tell us that the glass holds 473 cubic centimeters, which is the same as 16 fluid ounces. So what they're saying right there is that 1 glass is worth 16 fluid ounces. And once again, because 1 glass is 16 fluid ounces, this is the number 1, and we're allowed to multiply by the number 1 because nothing happens. So now we've got a situation where our units will be canceling away. Just making a little more space here. Our units will be canceling away. So we have gallons canceling with gallons, fluid ounces canceling with fluid ounces, and the only unit left is gallons. And why did I write the word glass there? Oh, that was supposed to be the word glass. Okay, fun stuff. So the only unit remaining is not gallons, it's glasses, cups. And how many glasses? 128 on the top, 16 on the bottom. 128 divided by 16, which is 8. And so the answer to number 11 is going to be B, 8. Number 12 has a brutal trick wording within it, which tells you more confirmation of why you have to be extra careful on the SAT. Make sure you get a good night's sleep the night before. And to go into an SAT and be successful, you're not going to say to yourself, I need to answer the toughest questions and I need to do rocket science. You need to tell yourself, I've got to be really careful, not miss a negative sign, not miss a little detail. The devil's in the details when it comes to the SAT, that's for sure. So it's a system of inequalities, so system of equations with greater than and less than. So generally it's a system of inequalities, but that's basically the same thing as a system of linear equations. So a system of linear inequalities. And the big thing we emphasize about these systems with these big word problems is to define the variables. So let's find out what X and Y are for sure. X is the number of 50,000 policies. Now, by the way, when we're looking for X and Y, it's either going to be the price or the quantity. So the price is that they're worth 50,000 each, and the quantity is what we need to make the variables. So X is the number of $50,000 policies, and Y is the number of $100,000 policies. So the question says his goal was to sell at least 57 policies. So X plus Y, if he sold 57, then it would be equal to 57. And if he sold at least 57, then that would be, at least would be greater is okay and more is okay. So at least 57 would be greater than or equal to, but that would be a mistake because in this brutal wording, it says right afterwards, he did not meet his goal. So he did not sell at least 57. So he didn't sell greater than 57 or equal to 57. He sold less than 57. And that is as brutal as it gets, in my opinion. But the value of what he sold, which is our price times quantity statement, it's our amount of money. So 50,000 times the number of 50,000 plus 100,000 times the number of 100,000, that was definitely over 3 million. So it was greater than 3 million with no tricks there. So X plus Y is less than 57. And 50,000 X plus 100,000 Y is greater than 3 million, which is this or this. So the answer that has them both for number 12 is going to be C. Let's go ahead and go now to number 13. Okay, number 13 gets at the idea of what is a negative exponent. Negative exponents mean that whatever has the negative exponent is on the wrong side of the fraction in terms of numerator and denominator. So negative exponents mean that whatever we're talking about that has the negative exponent is on the wrong side of the fraction. So a couple of quick examples of that. If I have x to the minus 5, well, that's really x to the minus 5 over 1, because any number is really itself over 1. But now the negative exponent means it's in the numerator, but it should be in the denominator. So we're going to take the x to the 5th and move it to the bottom, and that gets rid of the negative exponent. But what's left on the top? Well, there was always an invisible number 1 there, so there still is. So x to the negative 5 is the same as 1 over x to the 5. Or another example would be a over b to the c. but a over b to the negative c. If I had a over b to the c, it would just be a to the c over b to the c. But with the negative, that means that everything inside of this parentheses is on the wrong side of the fraction. So to get rid of that negative, we flip it over, move both things to the opposite side of the fraction, and taking care of that gets rid of the negative exponent. And now we would have b to the c over a to the c. So just a couple of applications of negative exponents in action. So for our question here, we have a to the negative 1/2 equals x. So a negative exponent, as it pertains to an equation like this with one term on each side, is the idea that to get rid of the negative exponent, we have to flip something. And whether we flip the left side of the equation or the right side of the equation, both of those are equivalent. Flipping something takes care of it. So on the one hand, we can say 1 over a to the 1/2 equals x. And on the other hand, we could say a to the 1/2 equals 1 over x. So we either flip the left side of the equation or the right side of the equation, and both of those get rid of the negative on the exponent. A little bit better handwriting right here. So this looks more like a to the 1/2 power. Okay, so we've got it there. Now we need to get a by itself. So of these two, if I were doing the one on the left, which we're not going to stick with, I would multiply by a to the 1/2 on both sides right here. And I would get 1 equals x times a to the 1/2. And then to get a by itself, now you divide by x. 1 over x equals a to the 1/2. But look at this one right here. It already was there. So out of these two options, the one on the right was the better one. Now we need to get a by itself. So what's a by itself? How do we get rid of that 1/2? We take advantage of this exponent rule that says if I have a to the b power to the c power, that's the same as a to the b times c power. So here, if I raise both sides to the second power, 1/2 times 2 is just 1. So it gets rid of the exponent. It makes it a to the first power, which is just a. And now we're squaring 1 over x. So 1 squared over x squared. 1 squared is just 1. So 1 over x squared is our answer. And number 13 is going to be C. Now we're going over to number 14. So number 14 is kind of quizzing us on our understanding of what makes an expression undefined values. And undefined values come from zeros in the denominator or negatives under a radical, but what I want to say is an even radical, because I am allowed to have a negative number under a cube root, because the cube root of negative 125 is actually negative 5, and there's nothing wrong with that. But it's an even radical. Like I can't have a negative number under a square root or a fourth root or a sixth root. Okay, so anyway, so we don't have radicals here, but we do have a denominator. And what values would cause zeros in this denominator right here? We can find that out by taking the denominator and just setting it equal to 0. So how do we find the value that makes it 0? We find that by setting it equal to 0, having a quadratic, which is what this kind of equation is called, equal to 0. That's our permission to factor. We have numbers in the b spot and the c spot, because a quadratic is the format of ax squared plus bx plus c. So notice we have numbers in the b and the c, but just the invisible 1 in the a. So in this situation, you do bc factoring, which is that we're looking for two numbers that add to b and multiply to c. So what two numbers add to 3 and multiply to negative 10? Well, first of all, they multiply to a negative. They multiply to a negative number. And when something multiplies to a negative number, that means that it has opposite signs. So for instance, what pair of numbers can multiply to a negative? A positive and a negative, or a negative and a positive. But a positive times a positive will be positive, and a negative times negative will be positive. So if you had the same signs for two things being multiplied, then the answer would be positive. So we have opposite signs, and the answer is positive or the answer from the sum of these two things, because they need to add to 3. So if the sum is positive for two numbers that have opposite signs, then that means that the bigger number, the bigger looking number, is the positive number. So we're looking for two. So, okay, so we have two numbers with opposite signs. The bigger looking one is the positive one. What are the factors of 10 anyway? 1 times 10, 2 times 5. So I need one pair of these numbers with opposite signs, and the bigger one is the positive one, and they need to add to 3 and multiply to negative 10. So that's these numbers right here. It would be 5 and negative 2. X plus 5, x minus 2 equals 0. The zero product rule says that at this stage in the game, we can set each of these things equal to 0. And you get negative 5 or positive 2 for the answers. So which two answers make this undefined? Negative 5 and positive 2 both do. But positive 2 is being given to us as an answer choice. So the answer to number 14 is going to be D. Now we're going to number 15 here. So we have a block in the shape of a prism, a rectangular prism. It's got dimensions in centimeters. The density is grams per centimeter. And we need the mass in grams. So as I'm reading through that, I'm looking for conflicting units. So we want to always check for conflicting units. Like for instance, if they talked about centimeters in one moment and about meters in another moment, we'd want to be aware of that so we can take care of that difference. But we know in our formula sheet that the SAT gives us that the volume of a rectangular prism is length times width times height. So here that's 30 centimeters times 40 centimeters times 50 centimeters, which I believe is 60,000. So yeah, we have 60,000 right there. And this might be a little trickier of a question for some people because it's not very evident where the instructions are. The instructions on what to do are actually here. The density is the mass per volume. So mass divided by volume. So per means divide. So the density, they said, was 2.8. The volume is 60,000. The mass is right here. And that is filling everything we know into this equation that they gave us. Now, if you multiply both sides by 60,000, you get 168,000. And so the answer to number 15 is going to be D. Now we're going over to number 16. When we have a probability question, particularly something with a chart like this, we want to ask, is it general probability or conditional probability? So probability in general is the part over the whole. So probability is just the part over the whole. So if I have 3 friends and one of them is going to give me $100, then the probability that my friend is going to give me $100 is 1 out of 3, the part over the whole. But conditional probability is a wonderful SAT topic because it does everything the SAT wants to do. It's more confusing while seeming like it's actually more simple. But conditional probability is the idea of shrinking the data or focusing on just part of the data is maybe a better way to say that. So what proportion of adults who received the sugar pill? So who received the sugar pill? These people did. And I'm not going to highlight the total because it'll feel like highlighting the same number twice. But these are the people who received the sugar pill. And what proportion of those people got the cold? So the people who got the cold is this part of that group right there. So how many people received the sugar pill? 150, which is the 33 plus 117. And how many of those 150 got the cold? 33 of them did. So the answer is 33 over 150. And it simplifies, divide by 3 on both sides, to 11 over 50. So the answer to number 16 is going to be B. Going over to number 17. The table shows the distribution of ages of 20 students enrolled in a college class. Here we go, sorry. The table shows the distribution of the ages of 20 students. What's the mean, median, and mode of the ages? So the mode, if we start with that one, is the one that's the most frequent. Now, I just know from experience that frequency charts are very confusing. People get them wrong very frequently, even though when we go over them, they're easy, but there's just something about frequency charts that freaks everybody out. So be a little careful about them. But the mode is the most frequent number in all of this. So there were 6 18s and 5 19s and 4 20s and so on. So the number that occurs the most frequently is the number 18. Why? Because there were 6 of them. Now getting into the median is the middle number when they're put in order. So they're already in order by age, 18, 19, 20, 21, and so on. And so how do we get the median without taking too much time and energy? We can kind of tally the answers up. So I'll show you what that means. If I count from here down, I counted how many values? I counted 11 values because that was 6 18s and 5 19s. So that's 11 values. If we count from the bottom upward, how many values is that? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, because there's 4 here. So that's 9 values right there. So it's kind of uneven. Getting to the middle number, we'd have to kind of keep pushing this way a little. So let's illustrate a little bit better. If we count from the top down right here, we have 6 numbers, right? Now we'll count 1, 2, 3, 4, 5, 6. So if I count 6 numbers, there I counted 5 numbers here. 2 plus 3 ones is just 5, right? So when we count 6, we've gotten out of this 4 that I'm highlighting in, pink, if I'm counting 6 numbers, I've counted one of those 4 and it still leaves 3 more. So let's go ahead and count all of those 4. So if I count up to here, once again, we did this in the beginning. This is 1, 2, 3, 4, 5, plus 4 more. So this is 9 numbers. So now we counted 9 numbers from the high end, from the 30 in, and 6 numbers from the low end in, right? So now if I want to even it out, that means that I need 3 more of these numbers, right? Because 3 plus 6 will be 9. So now I've got 9 down here and 9 going up. And so that means that we're taking this 5 and we're splitting it. We've got 3 of them are being accounted for, and we've got 2 more of the numbers that are right here, and that's your median. So just to show this better, one more time. So we're counting 9 numbers here and 9 more numbers here. And to do that, these are 11. 6 and 5 is 11, right? So I'm taking the 6 that we have of 18s and 3 of the 19s to 6 of the 18s and 3 of the 19s to give me the 9 numbers. That means out of the 5 19s, I've taken 3 of them and I have 2 more. So there are 2 more numbers here that are both in the middle of this data set. 2 numbers. And what are those 2 numbers? They're both 19s. So what's the middle number? It's the number 19. Now that's a little sort of harder to show. It's easier to do, but harder to show. And what I'm trying to model for you is like a quicker way to do this. Like if I'm counting from the top up, from the top downward and the bottom upward, I can kind of tally. So for instance, 1, 2, 3, 4, 5, I have 5. 6, 7, 8, 9, I have 9. Okay, now counting from the top downward. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now notice that there are just 2 more that I haven't counted, and those are the median, because now we have 9 here and 9 here. So just talking about how to make sense of frequency with median without wasting a lot of your time writing the numbers over and over again yourself. But that wouldn't actually be so bad, because look how quick I can do this. I've got 6 18s. I've got 5 19s. 4 20s. Zoom out a tiny bit. So we're just talking about different ways to find the median, which we already found. We've got 2 21s, 22, one of them, 23, one of them, and 30, one of them. So now, how can we count the median if we have the numbers written out like that? Just count inward. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 1. And now we get to the middle. And these are the 2 middle numbers. So if you have an even number of pieces of data, the median would actually be the average of these 2 numbers. So if these were different numbers, I would add them up and divide by 2 to find the median. But if you have an odd number of pieces of data, then there will be 1 number in the middle, and it'll be a little easier to find the median. So now we're talking about the mean of this. And the mean, the average, the real average, is the sum over the number of values. So basically, we're talking about adding up all these numbers and dividing by 20, because we knew from the beginning there were 20. But the way to do that a little quicker is, instead of adding 18 6 times, I'm going to say 18 times 6 plus 19 times 5. So you're multiplying the value with its frequency. 20 times 4 plus 21 times 2, 22, 23, and 30. And when you do that, you get 400 divided by 20. And so the mean is 20. So we've got the mode is 18. The median is 19. The mean is 20. And so writing it the way they have it, the mode is less than the median, which is less than the mean, because they're 18, 19, and 20. Mode, median, mean. And so the answer to number 17 should therefore be A. Going over to 18 now. '18 is this wonderful problem that we use as an example of the deceptive nature of the wordings on the SAT. So, a little difficult to discuss this without being a little negative with reference to the writers of this test, but we'll stay positive here as much as possible. But what's happening is, this is a question on wordiness more than anything. Now, technically, it's, the actual versus the predicted. So it's a common theme on the SAT. You have the actual values, which are the dots, versus the predicted values, which the predicted value, which is the line of best fit. So when we're looking at the dots versus the line, we need to know that that's the actual versus the predicted. But this is essentially just a graph of litter versus temperature. So at its face value, this graph is just saying that as the temperature goes up, the amount of litter remaining goes down. But they don't call it litter. They call it the percent of leaf litter mass remaining after decomposing for 3 years. So this is a quite overt attempt to take something really simple and make it more difficult by using more words. So The other axis is temperature. They don't call it temperature. They call it the mean annual temperature in degrees Celsius in 18 forests in Canada. So we were counting the number of syllables. It's actually just ridiculous how many syllables there are. And we do feel bad for our teens out there who are doing these tests. Really not so much, because the truth is, when you do a lot of this, you just get used to it. You start looking through all of that kind of complicatedness and just go for what you need. But there's no substitute for practice. You're not going to get there if you're not practicing regularly for this. So the question is saying there is a temperature of -2. So by the way, this would be like -2.5 right here, halfway between 0 and 5. So -2 would be like right here, somewhere along this line. And the question is saying, what is the predicted litter when the temperature is -2? So predicted is the line. So what's the value of the line when the x is -2? And the line is valued at around 70. So the answer to number 18 is going to be C. The biggest takeaway from this problem, is that on a graph like this, the actual value is the dots and the predicted value is the line. So let's go over to number 19 now. I'm just going to take a quick second to put these things near each other. So instead of having choices C and D below, we're going to have them next to it so that we can see more easily. So what's domain and what's range? The domain of a function is all the possible x values in the function. If you zoom all the way out, which x values are included in the function. And the range is the possible y values. So this question is telling us that the range of function f is real numbers that are less than or equal to 4. So you can go to the line of y, because range is the y value. Y equals 4. This is y equals 4 right here. And the graph should only exist below that line. And that's going to be true for answer choices A and B only. C and D. C goes above 4, and D has a range of all real numbers. It goes all the way up and all the way down. So now we're talking about the zeros. The zeros, it's a very important SAT word. The zeros, the x-intercepts, these are all the same thing. The roots, the solutions, and with one little minor tweak, the factors are also included in that. All these things basically mean the same thing. They're the x-intercepts. So the zeros, the x-intercepts, are -3 and 1. So which of these graphs, A or B, is hitting the x-axis at -3 or 1? And that's this one right here. Choice B hits at -1 and 3. So the answer number 19 is going to be A. And the biggest things to take out of this are that the domain is the possible x's, the range is the possible y's, and that zeros, x-intercepts, roots, solutions, and kind of factors all essentially mean the same thing. Now we're going over to number 20. Number 20 says, in terms of the main backbone of this problem, is that we want the total energy cost to exceed the installation cost. The total energy cost savings is going to exceed the installation cost. And we're talking about the savings over years. So what's savings? Savings is what you would have spent, in this case, 4,334, minus what you actually spent, 2,712. So if I would have spent 4,334, but I actually spent 2,712, the savings is the difference between those two numbers. And that's being saved every single year. So you're multiplying it by the number of years. And that needs to be greater than the installation cost, which is 25,000. So the right answer is the one that looks like this. And this is exactly equivalent to choice B, except it's reversed. So writing it this way is the same as saying that this 25,000 must be less than the difference between 4,334 and 2,712 times t. So that's number 20. Going over to question 21. 21 is giving us a little graph there, and they're saying, what's the best interpretation of the 3.39 in this problem? So they're giving us the function right here. And it's the same function we deal with a lot on the SAT. It's something in a nice y equals mx plus b format. So y equals mx plus b, and the question is saying that that's 3.39x plus 46.89. So they're asking us what's the 3.39, and that is the slope. So what this question is, it's a question on translating slope. And what do we mean by translating slope? It's going through the process of just saying that slope is your change in y over your change in x, and then converting that to the units of the question. So the y value is the plastic. So the triangle means change in the amount of plastic over the change in years. Now, by the way, in these expressions, the denominator is usually 1. So for every 1 year that changes, by how much does the plastic change? It changes by 3.39. So in other words, 3.39 is the same as 3.39 over 1. And that fraction means that we have a change of 3.39 for the billions of pounds of plastic per year. So the plastic changes by 3.39 for every 1 year that changes, every 1 year that goes by. So which answer says that? Just basically looking through the answer choices, we're looking for the one that matches the idea of the change in plastic per year. And the one that has a word that sort of speaks to change is choice D, which says the average annual increase in plastic per year. So the change in plastic per change in year, they're calling it the increase in plastic per year. So the answer to number 21 is going to be D. And now we're going to question 22. And we'll go ahead and just bring this graph in so we can see the question next to the graph. Which of the following is closest to the percent increase in the billions of pounds of plastic produced in the United States in this time frame? So percent increase is a loaded phrase. It's the idea of percent change. It's a formula that, you just can't get certain questions right without knowing this formula. The percent change is the change over the original. The way they teach it in school, it's the same formula, but it just sounds a lot more complicated. But we're looking for the change over the original. And by how much did it change from 2000 to 2013? So 2000 is 15 years after 1985. So that's the year 2000 right there. And 2003 is 18 years after 1985. So 2003 minus 1985 is 18. So this is the year 2003 right here. So from 2000 to 2003, how much did it change? To me, well, it didn't go up halfway. It looked like it went from like 1 to like 105, 106. So I'll say it changed. Okay, so it went from, let's say, 100 to 105. Let's use that. So what was the change? The change was 5. What was the original? 100. So that divides out to 0.05 on your calculator. And to convert between decimal and percent, you move the decimal 2 spaces to the right. So that's just going to be 5%. So which of the following is closest to the percent change that we got? I got something in the range of 5%. So the one that's closest is 10%. So the answer to number 22 is going to be A. And now we're going over to number 23. Okay, 23 can be kind of a vexing problem. Couple of ways to look at this one, but we'll pick the simplest one. First of all, an exponential equation is going to be something in the format of A times B to the X. A is the original amount. B is how it's changing, and we're changing by multiplying. And so X is the number of times that change takes place, because that's what an exponent is the idea that we're multiplying by something over and over again. So here in the original equation, we've got the M is 1800 times 1.02 to the T. Now, first of all, that 1.02, that's 102%. We talk about that a lot, which means that we're talking about a 2% increase. And T is the number of times that the 1800 is going to increase by 2%. Now, T is in years, and Q is quarter years. So for me, I would say the quickest way to convert between years and quarter years is to try a number. So as we change units, which expression is going to create the same change as the original equation is what they're asking us. So what I would do is I would say, well, 2 years is equal to 8 quarter years. 1 year is 4 quarters, so 2 years would be 8 quarters. So if we had a 2 right here, what that means is that this thing is going to be triggered twice. 1800 is going to rise by 2% 2 different times. Multiply by 1.02 and then multiply by 1.02 again. So in other words, that would be T is 2 because that's the number of years. So now when Q is 8, it's the same period of time. We're just in a different unit, excuse me. So now which of these expressions here would cause us to have the same 2 that we need, because we're talking about the same period of time? And so I would just try the number 8 in all of these. So here you have 8 over 4, which is 2. 4 times 8, which is 32. Once again, 4 times 8, which is 32. This one doesn't even have the same percentage, and neither does this one. So they're kind of besides the point. But notice that when you put 8 into choice A, you get an exponent of 2. So you get this thing to be triggered twice, which is exactly what we needed, because 8 quarter years is 2 years. So by trying a number, we were able to negotiate the difference. Now, on other problems that talk about the same concept, what you want to consider is, like, if I have my y equals a times b to the x, if I multiply right here, so let's say that I have y equals a times b to the 3x, versus if I divide. So let's say we have y equals a times b to the x over 3. Multiplying in this situation is saying that it's going to happen 3 times for every year, if x is the number of years, but we'll just say 3 times for every x. But dividing is the idea of saying that it's going to happen once every 3 years, or every 3 x's. So for instance, if I had a situation where the amount of money that I make is going to increase by 20% 3 times a year, then I'm going to want 3x in the exponent. So I have like my original amount of money, it's gonna double or multiply, it's gonna do whatever, it's gonna increase by 20% 3 times per year. So now just imagine I put the number 1 in for X. It's if I go by 1 year, it's gonna happen 3 times. Versus in the other one, let's say that my income is going to raise by 20% once every 3 years. So now I have my income, it's going to raise by 20%, which means I'm multiplying by 1.2. And now if that's happening every 3 years, that's the idea of dividing. So for instance, if 3 years goes by, if X is 3, then 3 over 3 right here is going to be 1, and this whole thing is going to be triggered once. So you need to kind of know for this more difficult SAT situation that multiplying means we're doing something multiple times every X, and dividing means that we're doing something every once in a while, every 3 X's. So very confusing, and I'm sort of treating this with some TLC in the way I'm trying to explain it because it is one of the harder concepts on the SAT. So let's go over to number 24 now. 24 is our data collection question. So the SAT asks us about research that was conducted, and it asks us if it was done correctly or not. So on a data collection question, there's 3 things to look out for. Number 1, you want no definitive statements. So we can never say what's definitely going to happen or what's 100% sure to be the case, because the best research in the world is just going to give you the best educated guess in the world. Number 2, we want no bias. Bias is in the people you pick for your experiment or the location you pick for your experiment. So for instance, I wouldn't want to go to a rock concert and ask people how many people there like rock and roll, because the fact that they're at a rock concert means that they like rock and roll. Last but not least, you can only reflect on what you studied. So the example I always give for that is if I want to know the opinion of all the 3rd graders around the United States, I shouldn't pick all the 3rd graders from one class at one school in the United States. I need a random sample of 3rd graders from all over the United States. So you can only reflect on exactly what you studied. The sort of descriptions of what you studied and what you're reflecting it on need to perfectly match each other. So these are the 3 basic things to look out for on a data collection question. So now just, just imagine you're on your SAT. This would just make a lot of teens say to themselves, like, the famous, wait, what, right? Because it's just so much information. But looking at the answer choices, we're seeing some amazing clues according to the 3 things we're looking out for. If all viewers had voted, contestant 2 would have won. The only person who knows that is God, what will be the case. That's a definitive statement. Viewers voting by social media were more likely to be younger. Well, we can only reflect on what we studied. So the fact that someone's likely to be younger, I don't see anything in here that is studying whether they were younger or older. So this is the idea that you can only reflect on what you studied. C, if all viewers who voted had voted by social media instead of by text, contestant 2 would have won. Once again, the only person who knows that is God. That's a definitive statement. They're saying what definitely would have happened, and we're not allowed to do that. We need a word like approximately, most likely, it appears to be the case, that just something that adds a little humility, because research is all about educated guesses, and that's the best we can do, is a really good educated guess. So choice D says exactly one of those phrases. It says more likely. So viewers voting by social media were more likely to prefer contestant 2. Now we got this far without really analyzing the numbers, but were the viewers on social media more likely to prefer contestant 2? Well, 30% of the ones were cast on social media. Contestant 2 earned 70% of the social media. And so therefore, it seems like contestant 1 earned 30% of the social media. So by what we studied, we found that viewers voting by social media were more likely. So likely is kind of a word that takes the edge off. It wasn't saying if this were to happen, this definitely would happen. It's just kind of just a little lighter in its wording. So it's more of the idea of the definitive statement. So let's go to number 25 now. So, okay. The wording of the X value here, the T value, is the years after 2000 on number 25. So although we would like to make our X values 2000 and 2010, that would be wrong according to the way they're doing it, The X values are 0 and 10. So they're not the years, they're the number of years after 2000. So in year 0, or the year 2000, population was 862. And in year 10, 2010, it was 846. Here we can get the slope. So y2 minus y1 over x2 minus x1. So just subtract the two y values and subtract the two x values in the same order. And 862 minus 846 is 16 over negative 10. So on a calculator, that's negative 1.6. So that means that the two answers that have a slope of negative 1.6, this is a y equals mx plus b written in the format of b plus mx. And this is the slope in your point slope formula. So it looks like y minus y1 equals m, x minus x1. So we see a slope of negative 1.6 in those two. Now, are we being given a slope and an intercept, or a point and a slope? Well, the y-intercept, which is the b and the slope-intercept, the y-intercept is when x equals 0. And right here, we do have x equaling 0. So we can call 862 our y-intercept. So in a y equals mx plus b, we have y equals negative 1.6x plus 862, which is exactly like choice A. They're using t and they're writing it with the 862 first, but it's the same thing. So now we're going over to number 26, and 26, once again, is another data collection question. So let's bring in the same rules for data collection. And we have question 26. So let's see here. Excuse me. So, okay, we have number 26 here. To determine the mean number of children per household, Tabitha went to a playground. What's wrong with that? A playground is the place where families with children are likely to go. So this is incredibly biased. When we're talking about bias on the SAT, a lot of times we're talking about volunteering. So these people volunteered to go to a playground because they had children. So this is just biased. And that is choice C. The sampling method is flawed and is going to produce a bias estimate. So nice and easy on a question that would have looked really difficult otherwise. Going over to number 27 now. Okay, the main point to make about 27 is the idea that when you're given a point, you want to plug it in. You're given a point, plug it in. So even if the point looks like something a little more complicated. So here we have PR on this line. So X is P when Y is R. So we'll plug that in. Y is R when X is P. And they're saying that this point lies on this line. So Y is 5R when X is 2P. So 5R equals 2X, X is 2P, plus B. So simplifying that a little. So starting this question, we've got our two expressions. R equals P plus B. 5R equals 4P plus B. Okay, so now the question is asking us to get R over P. And so getting R over P, another way to say that is we're getting rid of B. And one nice way to get rid of something you don't want is to solve for exactly that thing. I'll show you what I mean. Taking away P from both sides, you have R minus P equals B. And here, taking away 4P from both sides, you have 5R minus 4P equals B. So now both of these equations are equal to B, so they're both equal to each other. That's essentially the substitution method. So you got R minus P equals 5R minus 4P. And now we're trying to finagle this into R over P. So one thing you can do is get all the R's on one side and all the P's on one side. So I'll take away R from both sides and add 4P to both sides. So we have that right there. And we can go ahead and cancel the R's, cancel the 4P's. And so now we have 4P minus P here is 3P. 5R minus R is 4R. So we basically took all the P's and put them on one side, took all the R's and put them on the other side. And what we want is R over P. So one way to describe R over P is that it has R on the top and P on the bottom. So one thing we can do to simplify this is to simplify it in a way that gives us R on the top. So I'm going to multiply by 3P. I'm going to divide by 3P on both sides. So 3P divided by 3P is the number 1. And on the right, we have 4R over 3P. So we've got 4R over 3P. Make that a little neater there. But we want R over P. So we got 4R over 3P. We want R over P. So let's get rid of the 4 over 3 by multiplying by the opposite, 3 over 4. So now the 3 cancels with the 3, the 4 cancels with the 4, and we have R equals, on the left-hand side, 1 times 3/4. And we're done with number 27. The answer to 27 is B. So now we're going over to number 28. And 28 is this question here on the right. Okay, so 28 is asking us about standard deviation and range. So range for data is very different than domain and range for X's and Y's. Range for data is just the difference between the highest and lowest values in your data sets. So if we're being asked about the ranges here, then for 28, we just need to do 88, because there's 188 value, minus 56. And here we would need to do 112 minus 80. So 88 minus 56 on your calculator is 32. 112 minus 80 on your calculator is also 32. So the ranges are equal. So we have the ranges being equal, which means that the answers can only be A or D. Now going on to standard deviation. I don't really want to talk about standard deviation because standard deviation is this amazing and complicated statistical operation that you can learn in your AP stats class, or you can learn in, or you can learn it in, let's see, in many other classes like in college or something. But the way the SAT asks it is very, very oversimplified. So instead of talking about standard deviation, which is the real concept, let's just talk about deviation, the idea of deviating. If you deviate, you're going away from the norm. So what's a deviant in society? Is someone who's really, really not normal, very far away from the norm. And when we're talking about the norm and averages, we're talking about the center, the average, right? So more deviation means we have more values that are away from the norm. So more deviation means more values that are away from the center of everything. So the difference between these two charts is a perfect illustration of something that's going to have more deviation and less deviation. So here you have all the values centered around the center, or most of them are right here in the heart of it all. But on the other one, you have more of the values that are a little further away. It's more evenly spread out, right? So this one is going to be more standard deviation according to the SAT's definition. And this other one here is less standard deviation. So less deviation because the values are more centered. So more values that are away, less centered, that's more standard deviation. So the standard deviation of group 2 is greater than the standard deviation of group 1. And so that would be this one here or this one here. If one of them is greater than the other, then they're not equal. So the choice that has them both for number 28 is choice D. So number 29 is kind of a classic SAT question in terms of something that they do really frequently. They're asking us whether this growth is linear or exponential. That's the main thing that's being done here. The SAT is a very tricky test. So if it's linear, they're going to try to make you think it's exponential. And if it's exponential, they're going to try to make you think it's linear. Now, linear is your y equals mx plus b, and exponential is your y equals a times b to the x. Linear is the idea that as x increases, y is being added. Something is being added to y. And exponential is the idea that as x is increasing, we're multiplying y by something. So the question here is which one is happening? So they're telling us that this is being copied at a constant rate. So as more time goes on, more papers are being added on at a constant rate. So that's going to be linear. But they definitely went out of their way to make us think it was exponential, because an exponential situation would be something that uses a percent. So for instance, I start with a certain amount of money and I lose 30% every year. That would be an exponential situation. So that's what they're trying to do in green there, is they're trying to make us feel like this is exponential, although it's linear. So now we can view this question, now that we know it's linear, we know it's a y equals mx plus b, we can view it as 2 points. When 0 minutes has gone by at the beginning of this all, there were 5,000 sheets of paper. When 20 minutes goes by, we've used 30% of the paper. So let's talk about that really quickly. When you're dealing with percents, you start at 100%. If you lose 30%, it goes to 70%. If you gain 30%, it goes to 130%. And in decimal form, this would mean multiplying by 0.70, and this would mean multiplying by 1.3. So here we're losing 30%, we're using 30% of the paper. So in order to find out how much paper is left, we actually have to take 5,000 and multiply it by 0.70, which is going to give us 3,500. So after 20 minutes, there's 3,500. There are 3,500 sheets of paper left. Now that we have that set up, we can just go ahead and find the slope. The slope is your y2 minus y1, 3,500 minus 5,000 over x2 minus x1. So you could kind of go in either order with that as long as you're consistent. So we have negative 1,500 over 20. 1,500 divided by 20 is 75. So the answer is negative 75 for the slope. So we have a linear equation with a slope of negative 75. And by the way, the y-intercept is 5,000. So the equation would have been y equals negative 75x plus 5,000, using x and y instead of p and m, but it's the same thing. And of course, the answer choice is going to present it this way because it's just a hair more challenging. But that is the same as this because we are using x and y because it's the classic thing, but the question is using p and m, which is totally fine. So the answer to number 29 is B. Going over to number 30 now. '30 is just kind of asking us for our understanding of f of x notation and maxes and mins. The question is saying the maximum value of f is k. So f is this function. We're seeing it graphed. And g is this function. We're seeing the values in the table, but we're not seeing the graph. So for one of them, you're seeing the values in the table. For the other one, you're seeing the actual graph of it. But more importantly, if I want the actual maximum or minimum of a function, that's our y value. But if I'm being asked where is the max or the min, where can I find it? That's more of a reference to the x. So little subtle wordings there as far as what we're looking for. But they're not asking where to find the maximum value of f, the green function. Where we would find it would be at x equals 4. And if they were asking it that way, then the answer for k would be 4. But they're asking what is the actual maximum value? The actual maximum value is the highest point when x is 4, it reaches a height of 3. So the maximum value of f is k, and that's 3. So k is 3. Now we're going to g of k. They're saying, what's g of k? So if k is 3 and we need g of k, then that's g of 3. So we're going into the g function, which is the blue chart now. And in f of x notation, if I give you an f of x, or in this situation, a g of x, or g of k, what have you. But if I give you something like that, and then I say substitute 3 into the parentheses, what we're really saying is that x is 3. But if I said, on the other hand, that g of x equals 3, the whole g of x is the y. So this would be a way to say y is 3. The way that they said it to us is a way to say x is 3. So we're basically looking for the value of g of x when x is 3, g of x is 6, and the answer is 6. So I did a lot of writing here because I'm really trying to explain to you what you need to know to understand this. But this is the definition of a good SAT question, because we really don't need to actually do any figuring here. You could just find the maximum value of f, which is 3, and then do g of 3, which is 6. You could literally get this question done in 2 or 3 seconds. Although I wouldn't advise it, because on the SAT, what we're really trying to do is just be extra careful when we do things. Now we're going to number 31. 31 is giving us 3 things to think about. They're giving us the hydrogen, the oxygen, and the water. So if I want to stay organized here, I might just create a little chart: hydrogen, oxygen, and water. And they're saying that there's 2 hydrogens and 1 oxygen in 1 water. And how many hydrogens are there when there's 51 waters? So when you can set up a chart for things that are proportional, then anywhere where you see a rectangle in that chart, you can go ahead and write a proportion. So here we see a rectangle, a rectangular shape there. So that allows us to write a proportion and say 2 over 1 equals x over 51. Cross multiply, 2 times 51 equals x times 1, and x now equals 102. And the answer to number 31 should be 102. Going over to question 32. (32) is telling us x equals 1. So let's just plug that in. X is 1. So we'll say 1 minus 1/2 a equals 0. Add 1/2 a to both sides. 1 equals 1/2 a. Now we can multiply by 2 to get rid of the denominator of the 1/2. And now we have 2 equals a, because the 2's canceled here. And the answer to number 32 is just 2. It just seems too easy. Going over now to number 33. The equations x plus 2y equals 10 and 3x plus 6y equals c represent the same line. That's really critical. We're talking about two lines and the way they interact on an xy axis, and there's three ways that that can happen. The lines can intersect once, they can intersect never, or they can intersect always if they were the same line. And that's what we have here. They're intersecting always. They're the same line. So what does it mean to be the same? It means every corresponding part matches up, the slopes and the y-intercepts. So there's a couple of ways to do this. But if they're the same line, they're just the same equation. A really easy way to do this is to just line them up. So you have x plus 2y equals 10. And 3x plus 6y equals c. So these are the same equations as one another, and they're already lined up. So how did we get from x to 3x? We multiplied by 3. 2y to 6y, we multiplied by 3. So how should we get from 10 to c? By multiplying by 3 again. And so c would simply be 30 for question 33. Now we're going over to question 34. Okay, so here they said, going straight, he would have traveled 11 miles in 26 minutes, but they're asking us to convert it to miles per hour. So 11 miles in 26 minutes, and there are 60 minutes in 1 hour. And like we always say here, this whole fraction on the right is equal to just the number 1, because 60 minutes and 1 hour are the same thing as each other. So it's a fraction with the same values on the top and the bottom. It's just the number 1. Now we could have said 60 minutes over 1 hour or 1 hour over 60 minutes, but we purposely put the minutes on the top because it's going to cancel. The units cancel just like a number or a variable. And you get 11 times 60 divided by 26. And the units remaining are miles per hour. So what's 11 times 60 divided by 26? 25.38. But they're asking to the nearest tenth, so we'll say 25.4. And that's the answer for number 34, 25.4. Going over now to number 35. So 35 is asking us about the moment that f of a equals g of a. Right here it's saying f of a equals g of a for number 35. So if we had said f of x equals g of x, if the question had said that, then more people would be likely to just take the f of x function and set it equal to the g of x function. So the writers of this test know that by saying f of a instead of f of x, it makes it a little less obvious that you're supposed to set them equal. But a is just some number, and so they're saying that when we plug in some number on the x value, it's equal to plugging in some number on the x value for the g function. So if you do it for the f, it's equal to doing it for the g. So basically set f equal to g. So -1/2 x minus 4 squared plus 10 equals -x plus 10. Now we can multiply both sides by -2. And we get x minus 4 squared, because it'll cancel against the -1/2, minus 20 equals 2x minus 20. So maybe we could have done this before, but with the 10s, you have 10 on both sides, they could just cancel. But we can do the same thing here. We have 20s, and they just cancel. So x minus 4 squared now equals 2x. So squaring it is the same as writing them side by side. So x minus 4 times x minus 4. And now we can FOIL it. First times first is x squared. Outer times outer. Inner times inner. Last times last. And we're just simplifying now. Combine our like terms right here. X squared minus 8x plus 16 equals 2x. So this is just a quadratic solving situation. And we say to ourselves right here, we say, this is a quadratic. A quadratic has y to the first power and x to the second power. And the reason we do that is because a quadratic equals 0. So take away 2x from both sides. X squared minus 10x plus 16 equals 0. And now we're in our B, C factoring situation because we have numbers in the B and C spots, but nothing in the A spot. So we're looking for two numbers that add to B and multiply to C. Two numbers that add to negative 10 and multiply to 16. So they multiply to a positive, which means the signs are the same. They add to a negative, which means they're both negative numbers. So what two negative numbers add to negative 10 and multiply to 16? Negative 2 and negative 8. So it factors to x minus 2, x minus 8. And you set each of those equal to 0. X minus 2 equals 0, which means that x equals 2. X minus 8 equals 0, which means that x equals 8. And the answer to number 35 is going to be 2 or 8. If you were to bubble in either of those answers, you would get the question right. So now we have number 36. 36 is getting at the idea that the co-functions, let's go ahead and reset this. It's getting at the idea that co-functions of complementary angles are equal. So very important little saying for the SAT. And they just give this same situation in different ways on different tests. So when we're talking about co-functions, we're talking about sine and cosine. So I'm seeing co-functions, sine and cosine. In real trigonometry, that would also be tan and cotan or secant and cosecant, but we haven't seen those show up on SATs, sine and cosine. Complementary means the two angles add up to 90. So when I have a sine, cos, or tan trigonometry expression, the thing after the sine, cos, or tan is the angle. So cos of this angle and sine of this angle. So if those two angles are complementary, then yes, we have co-functions of complementary angles. So the question is telling us to put point W right here, and there's a segment from S to W. If I can draw that, it's best I can do. And that's essentially dividing this into angle 1 and angle 2. Now, are angle 1 and angle 2 complementary? They are, because we just broke down a 90-degree angle into two angles. So of course, those two angles add to 90. So once again, we have co-functions, we have complementary. Therefore, we're able to say that the two expressions are equal. So what two expressions are equal? One of the trig expressions and the other one are equal to one another. So here, if I'm subtracting two things that are equal, the answer is just 0. And that's all there is to this question. So although if you're seeing it for the first time, it could look a little complicated, these are the SAT questions we like because we didn't have to write anything down. It was just a matter of understanding and just writing down the number 0 and moving to the next question. But another way to understand co-functions of complementary angles are equal is to say that if A plus B equals 90, then we're allowed to say that the sine of A equals the cosine of B, or vice versa. The cosine of A equals the sine of B. So here we had our two angles that did equal 90, angle 1 and angle 2 equal 90. And so therefore the sine, the cosine of one of them equals the sine of the other one. So the idea here was simply that this expression was equal to this expression. And when you subtract them out, you subtract two things that are equal to each other, and you're just going to end up with 0. So now we're going to number 37. 37 on this test is one of the harder SAT concepts. If you're really an ambitious student, really genuinely trying to get a high score on the SAT, you're going to want to know about question 37. And I'm just going to paste this next to the actual question so we can see more easily. But question 37 is the idea of unit conversions that come from a table. And I'll show you what that means. Okay. So 37 is the idea of unit conversions from a table. It's actually quite interesting because if I have a table of conversions, like everything here is talking about the number of micrograms per milliliter. This is telling you how to convert between micrograms and milliliters depending on the number of minutes after the injection. So there's a different conversion depending on how many minutes have passed since the injection. So when we have 10 milliliters of blood, that blood was drawn 5 minutes after. So 5 minutes after, we're talking about 152, and 152 what? Micrograms per milliliter. So right there we have 1,520, 10 times 152, and the milliliters cancel, one on the top, one on the bottom, and so now our unit is micrograms. For the 8 milliliters of blood that they talk about later in the problem, those are drawn 10 minutes after the injection. So 10 minutes after, we're talking about 118 micrograms per milliliter. 118 micrograms per milliliter. So milliliters cancels with milliliters, again, one on the top, one on the bottom. And 118 times 8 is 944. And the unit is micrograms. So we've converted to micrograms depending on the different unit conversions at each of the number of minutes after the injection. So the question is saying, how many more micrograms did we have for the first figure as compared to the second figure? So how many more is 1520 compared to 944? How many more is just code for subtraction? So 1520, 1,520 minus 944, and the difference is 576. So the answer to this question says that the first value was 576 more than the second value. And we have seen unit conversions from a table from time to time throughout different SATs that we've been able to view. So looking at number 38 now, 38 says P, which is the function that they're giving us right here, P approximates the values in the table to within 10 micrograms per milliliter. So that sentence tends to intimidate students, but all it's saying is that the P function, 200b to the t over 5, goes with the table, is what they're saying. So in other words, values from the table can be plugged into that function. That's what they're really saying. Now, if we take the 0 and 200 and plug that in, the 0 causes the whole right-hand side of the equation to disappear. So we can't use that first value. But if we plug in 5 and 152, we have P of t equals 200b to the t over 5. And t is the time, so that's going to be our 5 right there. So 5 over 5. So we have 200b to the 5 over 5, and that equals 152, because that's the value of P at that moment. P is the penicillin concentration. So now we've got something that we can solve for B. We can divide both sides. Well, first of all, 5 over 5 is 1. So 152 equals 200b to the 1. dividing by 200 on both sides, b equals 152 divided by 200, which to the nearest tenth is 0.8. So the answer to number 32 is 0.8. And that's the answer to number 38. And thanks for joining us as we've done all the solutions to section 4 of SAT Practice Test 8, which is freely available on College Board's website. Definitely let us know any feedback. Definitely comment if you have anything to let us know. And Gradeful can be tutoring you one-on-one, regardless of where in the world you live. You could be starting on getting ready to pursue your college dreams and go ahead and get yourself into the best college you can. And you can be doing that as early as today. Go ahead and reach out to us or send a text message to our number, which is 347-474-7150. Take care.